Hi, my name is Ted Tasker. I'm the Chief Technical Officer of BI Voyage. Thanks for watching this Take 5 where we're going to demonstrate PDW parallelism. So PDW is two things. It's hardware that scales up, right? In this example, we're talking about a half rack because that's what I'll be demonstrating on, a half rack appliance from HP where we have 4 compute nodes and a control node. Basically, a control node is going to be the brains of the operation, take your SQL, figure out how to run it on multiple servers. But the key is also software based, and it's a new table type, whether the table is distributed or replicate. Replicate means we'll take the smaller tables we have and make a full copy of them on each of the compute nodes. But a distribute table is a table that we're going to split up so that one row exists only in one and only one distribution. And we're actually going to put 8 distributions across each of the compute nodes. The reason we do this is so that a compute node can resolve some of the query independently. If I'm selecting my big table, all the fields from my big table join my 2 small tables, each compute node can figure out which records from the big table meet the criteria and just return their portion of the records. I'm now connected to BI Voyage's half rack appliance. You can see here on this performance grids that I have compute nodes 4, 3, 2, and 1. So there's our 4 compute nodes. This is part of the admin console that ships with PDW v1. You can see I've got processor time, disk reads, and disk writes. I'm going to close the disk writes, and I'm going to drill into a specific compute node 1. What comes up now is, for that particular compute node, G through G data 08, as well as some other drives. But these are the ones of real interest to us. Remember when we talked about distributed tables, we said that when you distribute, there's 8 copies of a table per compute node, and they go across these 8 LUNs. So what we're going to see when I execute this query, which is going against a 70 billion row table, however, it's doing it with a subset of data, is we're going to see the reads light up across all 4 compute nodes, and then even within a single compute node, you can see that we read across all 8 LUNs. So what we end up with is a great spread across the hardware in terms of servers, but within an individual server as well. We can see this even more if we go over to the Query tab and look at the specific query that we're running. So what we see right here, this text is what gets submitted to the control node, and down at the bottom, this is the distribution plan that the control node came up with. Again, the control node has to take a standard query and figure out how to run it on an MPP system. So I'm going to drill into the details, and what we're going to see is that distribution ID, we're going to scroll down, we're going to see that we've got 1 through 32 doing a hash reader, and then 1 through 32 doing a writer. So basically each compute node is running 8 selects to get the data that it wants, and then it's writing it out into temp tables so that the control node can consolidate all that information together. So in parallel, we had 32 queries executing. Refresh again just to see what our final status here is, to see if we've completed running. We have, is complete. You can see the start time was identical. Everything started at the same time. The run times are a little different, or the duration for each compute node. That's because some buckets may have a few more records. A compute node may have been busy doing some OS level stuff as well, so there's always a little bit of resource contention that might go on a server. But in general, they all ran from 49 to 54 seconds, and our total duration was 54 seconds. So in some ways, it might seem like we have some complexity here, some extra complexity. I had 3 tables, small 1 and 2 and big, but yet on the appliance, it's actually 40 tables. But the key is it's on the appliance, it's 40. The complexity is hidden by the appliance. To the end user, they're just thinking about that logical database. They're writing a query from Excel against their big table, not the 32 tables underneath. The DBA, if they need to create statistics on the big table. The control node turns that into the individual 32 create stats that are required. The demonstration we saw showed us how those 4 compute nodes got leveraged by the software to not only be running across 4 computers, but across the 32 LUNs, with core affinity working, 32 simultaneous selects running. It's a hardware and software scalability story. This has been a Take 5. Thanks for watching. If you'd like more information, please contact Joe Anstein at BI Voyage.